Hi there. Today we are going to talk about a little about Jakarta and NoSQL and cloud and how we can use it to actually solve problems. That's why we are here. We are much more than just programmers, just to using tools and so on. But we are here to solve problems. And what I've just built here in this presentation is using some kind of tools that I like it, tools that are useful, tools that are very, let's say, famous today to actually solve problems. So let's go to the presentation and enjoy it. Well, when we're thinking about a kind of problem that I would like to solve, use some different tools that we will discuss today. I imagine a recommendation application, recommendation software, where, for example, I would have a developer, a software developer. In this developer has like or enjoy or know or domain some kind of language, and this language he or her domain in some level. Okay, so advanced, regular, medium, or beginner. And this developer lives in some city. So, for example, Äôre, I I'm a Java developer, and talking about Java, I'm advanced. But for example, I know a little about Go, but for Go, I'm a beginner. And I live in São Paulo most of the time, but I also spend a lot of time in the year in San Francisco. So maybe I could add San Francisco here. So the point, the target of the application is send me, Elder, some recommendations related to the technologies that I like or I would like to work with. So, for example, if I'm in São Paulo, I would like that this tool, this application that I'm about to develop, to send me recommendations related to Java and maybe some other people work with Java in advanced level or just Java on itself, and maybe people that work with Java and live in São Paulo or live in San Francisco or maybe in the neighbor areas of these both cities. Okay, so let's go ahead and presentation, see some tools that we can use for that and how they can work together. So the first tool that I've chosen for our problem that we would like to solve is Jakarta EE. And not just because I like Jakarta EE, but it's because it is very powerful, very useful. I have been using it for a long time, even before J2E. Well, why Jakarta EE? Well, let's first think about why Jakarta is not dead. Some people think that it is dead since Java EE. Oh, Java is dead, Jakarta is dead, it's not used for anymore. Well, I would say for you that we have still many publications have been published for Jakarta EE, Java EE. I myself have published a book about Java EE 8. We still have a lot of developers around the world. One of the most used frameworks in the whole world is Java EE or Jakarta EE, right now with the new name. We still have a lot of career opportunities if you want to work with Jakarta EE and you are good at it. You still have a lot of opportunities, a lot of positions open in the market, in the industry. Well, as the specification, there is a lot of compatible application servers, so you have a lot of choices. If you're the company that you are working or would like to work are using one kind of application server and the other has another choice, you can work with both of them because it's specification. It has a standard, so you can build your application, follow the standards. And of course, there are a lot of user groups around the world working with Jakarta EE, contributing to the specifications and get involved. So, yet it's a vibrant community, a vibrant technology framework, and there's a lot of things happening. And if you think about the companies that is using Jakarta EE today, nowadays, I have a couple of examples in this slide. These one are companies that publicly has said that they are using Jakarta EE. Of course, just a few of them, but for that you have an idea of how much companies and how big they are, how small also, small companies also use Jakarta EE. But here we had a couple of examples, companies using Jakarta EE. I'm sure that most of you already know that in 2017, Oracle has announced that it was transferring Java EE by that time to Eclipse Foundation. Java EE, yes, was already an open source project, but this movement to Eclipse Foundation has a lot of implications related to open source. Now the point is to have Java EE much more open, much more balanced between all the people, all the stakeholders that are working with Jakarta EE. We have much more balance than before. So, for example, talking about roadmap, what's being moved from Oracle to Eclipse Foundation? Basically, the specifications, the APIs, the the reference implementation, and the TCK, the test framework. All those parts are being transferred from Oracle to Eclipse Foundation. And what won't be transferred is the trademark. Basically, that's why we need to change the name from Java EE to Jakarta EE. So that's about the transferring process. And if you are asking about the status that we have today, it's this image was taken just today, and this is the position. Okay, now we are in 2nd May. So if you see this graph, you can see that almost all projects has already its first release review. We have here all the milestones for each part: 20%, 4%, 60%, 80%. And you can see here that the Jakarta EE platform is in the 80%. So we had already the initial contribution to the Git repository. So maybe here we have missing just some kind of IP transferring and so on. Okay, and other projects like Jakarta Batch, Jakarta NoSQL, sorry, the first project that has born already under the Eclipse Foundation project for Jakarta EE. Well, so if you think about some kind of name, how they can have changed from Oracle to Eclipse Foundation. So for example, we had Glassfish, that is now Eclipse Glassfish. We had the former JCP, Java Community Process, that has not ended, it still exists. It has the stewardship over all the Java SC projects and specifications. The equivalents from JCP to Eclipse Foundation, we had now the Jakarta EE working group that is working on all those aspects from Jakarta EE project. And what was called in Oracle the Oracle Development Management, now we have the Eclipse Enterprise for Java, that is the project umbrella for Jakarta EE, and we had also the Project Management Committee, or the PMC. That's the group that is leading all these projects, all the groups, all the specifications for Jakarta EE. We can't talk today about Java Enterprise without talking about microprofile, because we are in the microservice era age. We are in the days that everybody's talking about microservice in some way, and as Java developers we can't stay behind, we can't stay out of this conversation, and we have the right tool for that, that is microprofile. And microprofile was born from Java EE as an optimization for enterprise Java in the way that we think about microservice. So yes, it's an optimization for enterprise Java for microservice architecture, and the point here is have to a much more faster pace. So they talk a lot about innovate, solidify, release, and repeat. So it's a cycle where you have much more a kind of MVP approach in the way that once we have a feature working and compatible and in a specification way, we can then release it, and then we will go back and innovate and get this innovation solidified and release and repeat and so on. So yeah, microprofile, it's the way of doing Java Enterprise for microservice. And in our problem that we are trying to solve, the recommendation system for our developers working with technology and living in cities, it's very useful to have microprofile as approach for Java EE in a microservice way. So there was some specification that was born under the microprofile project. So we have here config, health check, metrics, fault tolerance, REST client, OpenAPI, JWT, and open tracing. All of them were born under the microprofile, and there were others APIs that were brought from Java EE, for example, JAX-RS, CDI, and so on. So yes, we are talking about huge applications that we recommend developers for each other, that we recommend people, and we today talk about massive data, massive amount of data that are being communicating to the cloud between different applications and servers and around. So yes, today it's very makes a lot of sense to talk about NoSQL databases, because especially when we think about microservices, we have all those microservices spread in different networks, different technologies, and so on. So the kind of consistency that we have in the database is not what we were used in the monolith way. So it makes sense to talk about NoSQL when we are talking about this kind of applications. So well, when we think about NoSQL, we can say also, of course, there is a database. Usually it doesn't have a structure. In most of cases, we don't have a transaction. There are some discussions about have some kind of transaction on NoSQL database, but nowadays we can say that there is no transaction. The way that we think about data in NoSQL, it's the base way, where we can say that the database is basically available. You can affirm that it is always available. The state, it's not so strong. in the way that we think about it in relational database, and the consistency is eventual. Okay, so in some points the data will be consistent, but it's eventual. Okay, and we have 5 different types of NoSQL database that we will discuss right here. So in these logos in the right side, you can see some kind of examples of NoSQL databases. So the first kind of NoSQL database is the key value, on where basically we have a key and a value. It's a pair. So here we have Apollo and Sun, we have here Eros and War, and we have Aphrodite with Love and Beauty. So it's a key value kind of data. It's the most simple kind of data. The other kind of NoSQL database that we have is column family. So for example, not for example, but really talking about columns. So we have the row key and the columns. For example, here we have Apollo with the duty Sun. We have Aphrodite with the duty Love and Happy, and color is pink. And we have Ares with duty War, and we have different columns for if you would like to. For example, we have Kratos, and that not duty. We have Dead Gods 13, and we have the weapon sword. So we can mix the columns for each row key. Another kind of database, NoSQL database, is document. Basically, it's a JSON for each document we can store. So here we have Diana with duty Hunt, Moon, and Nature, and her siblings is Apollo, and the data is brother. And we have the graph databases, where we have much more complex kind of relationships. So for example, I can say that Apollo was killed by Kratos, and that Kratos killed Apollo. The same for Ares. And we have here another relationship between Apollo and Ares as siblings. And I can't say that Ares killed Kratos, because of course it was killed. And we have another kind of relationship in the graphs, that we have properties in the relationships. So that's the different way to see data relationships in the graph database. So, and we have also the multi-model NoSQL database. So for example, the Äôre DB is graph and document. The Couchbase implements key value and document. DB implements column family, graph, and key value. And Elasticsearch implements the document and graph. Okay. Yes. And if you think about the complexity and scalability for this kind of NoSQL database, we can have this graph. So for example, the key value has the less complexity, but it scales a lot. In the other extreme, we have the graph that has a lot of complexity but less scalability. And if we compare it to relationship databases, it would be just in the middle of graph and document. A little less complexity than graph, and a little more scalability, but less than document databases. And well, as you just saw, when we think about NoSQL database, there's a lot of different approaches, a lot of different ways of dealing with data. But you know, as a developer, if you would like to work with these different NoSQL database, it would be a pain, because each database Even if you are working with the same type, for example, a graph or a document, each different implementation has its own language, its own way to work with. So some people, some smart people, has built this project, this incredible project that is called Eclipse NoSQL. That's the main point is to have just one framework to access different kind of NoSQL databases. So the main point, the four main points for NoSQL is to have a mapping API, just one mapping API, okay, different mapping APIs for each kind of database, but all of them in the same framework. So for example, if you are mapping a graph database, you are mapping the same way for any graph database that you are using. Can be Oracle, can be Graph, can be Neo4j, or another one that you would like to use. It is also a communication API. Okay, so in the framework you can communicate the same way using the same API. It brings no locking, so if you are not using anymore the specific way to write your queries, to write your searches, your comments, to put data or to delete data or whatever, you are not having a locking anymore. And also another, the 4 points is to divide and conquer. So for example, for each driver, for each kind of different databases, they are counting on their own companies to write those drivers. So for example, Oracle engineers are writing the drivers for Oracle database. The Neo4j engineers are writing the drivers for Neo4j, the same for Cassandra, Redis, and so on. And here we have the schema, how NoSQL works. So we have the data access object on the top, and we have NoSQL working in the mapping with the Artemis, that is a project that was brought to the inside the NoSQL framework. And we have the communication layer with Diana, another project that was brought to the framework. And down here we have in the data tier, or in the top of the data tier, all kinds of different NoSQL databases, which each one with its own implementation, but all of them in the same API, communication, mapping, and so in this way we have just one single solution for access different NoSQL databases. And our discussion here is to bring the Jakarta EE to meet NoSQL, and in this meeting happening in the cloud. So we brought out also to discussion the Cloud Native Computer Foundation. And why? Because the CNCF has some kind of standards when we are talking about cloud native application, and we can't build today this kind of solution to our problem, to our developer in the city and with technologies, building this recommendation. We can't do it today without thinking about cloud native application, because our applications are born in today as a cloud native. So what CNCF says that we need to think about when we are building cloud native application? Basically, we can mention here 3 points. First, the application should be containerized. So today we can think about it as Docker containers, as a Kubernetes, deployed applications. This application needs to be dynamically orchestrated. So again, talk about Kubernetes, talk about any kind of orchestration tools, and should be microservice oriented. So we have already talked here about microprofile. So that's a good way to fulfill this approach from CNCF as to deploy our application in microservice oriented way. So yes, our problem is solved here. We came from the Jakarta EE to build a reliable application, use a mature framework. We can have our application built from Jakarta EE since the first line of code. We also brought to our party the NoSQL database, where we can have a massive amount of data spread in different regions, different kind of NoSQL databases and different implementations. And we have also microprofile, so our application here can have many microservers being implemented and spreaded and distributed in our architecture, and all of this in a cloud native way of doing microservices, of doing applications. And then we can, in this way, we can have our recommendation system being built in a very successful way. So thank you very much. Hope you enjoyed, and we have here my contacts, and you can reach me. So thanks for watching. Bye bye.